Good morning. My name is Sbongani David Khanyile, student number 15305783. Today, I would like to present to you a water infrastructure and resource management project for semester 1. On a daily basis, the need of water grows. If suitable water distribution networks are not built, it will have an influence on the water supply of the entire region served by the system. Before developing a water distribution system, and in-depth assessments of surrounding accessible water resources, present distribution network, water demand are, are needed. To design the following project, we're going to use the software called EPNet. EPNet is used to model water distribution system and to design, size the water infrastructure, optimize operation of the tanks, pumps, reduce energy usage, investigate water quality problems, and finally prepare for emergencies. For background overview, water distribution system acts as a conduit to reliable transport adequate quantity of safe drinking water to consumers, which are citizens. To achieve this, the system needs to work as, as intended and maintain a physical barrier between the water inside the network and the external environment. The physical integrity of the system refers to its ability to correct functioning component and maintain physical barrier between water in the network and external environment. Another definition of physical integrity is the ability of the distribution system to handle internal and external stresses in such a way that its components do not fail. Water distribution system consists of a complex combination of components including pipes, fittings, pumps, reservoirs, valves, hydrants, meters, backflow preventers that are all critical in maintaining the physical integrity. At the same time, the distribution system is constantly changing through the aging, replacement of component, and additional of new extensions. A reliable a reliable drinking water distribution system must be able to supply and deliver water within accessible quality to all its users at their delivery point. The reliability of the water distribution system is one of the very important factors in ensuring public safety, continuous operation of urban and rural activity. In this manner, we carefully um, carefully preparation of infrastructural planning and resources of allocation and maintenance and operational activities for water distribution system is very important. Optimal reliability and maintenance schemes are beneficial to the receiver of the service delivery and will not keep a sorry reliable and reliability and maintenance of the water distribution schemes. If if used correctly, it will merely keep the money of the government, which is will not overspend or keep maintaining the infrastructure in terms of fixing, maintaining every month, and also making sure that the water is being delivered in in a quality manner. But It will also improve the government service delivery, which I have mentioned before. And also, this will also be good for water distribution system because it will extend its lifespan. The aim of this study, as an engineering technologist, I've been appointed to make an I've been appointed to make an analysis of a water supply project to be implemented in Tsepise local municipality. The project is intended to provide water supply to four townships in line with the Water Services Development Plan. I am I am expected to determine the following: the number of pipes that are required, storage capacity of the bulk reservoir, head loss for each component, hydraulic profile for pumping mains, and also pipe sizes. I'll also consider the following: hydraulic profile for gravity mains, evaluate the need for the pressure and surge control. I must take the following into consideration. The water supply system must be designed to achieve appropriate water pressure and flow to avoid contamination to potable water, as well as achieving the right pressure and flow. The system must be suitable for the temperature of water carried, and well-designed installed system will also be durable and minimize the noise of the water problems. The, uh, the, the proposed demands is as follows. For township number 1, the average demand is 60, township number 2, 75, township number 3, 85, and finally township number 4, which is 135. The general layout of the proposed system is as follows. We'll, we will abstract the water from Inyangwe River, from Inyangwe to Shikilo water treatment plants, from Shikilo to bulk storage river we're gonna store water. From then we distribute it to the proposed township, which will consider calling them demand center number 1, 2, 3, and 4. We will consider the followings, which are the size of the pipes, the junctions, the pumps, which plays a huge role in distributing, distributing the water to the community. The following is the general layout of the township, which we see the township number 1, 2, 3, and 4. And in the center is the hill, which will make it very challenging for us to, or we need to take that into consideration, since we need to consider the flow of the water and also making sure that there is no obstruction towards the flow or the process of getting the water to the community. Now we're going to look at the literature view. The analysis of hydraulic problem evolved considerable over the years. Technology has played a big role in making the analysis of this problem less tedious and also assisting in reducing calculation to reach solution much quicker. Through technology and available of computer software, it has become easier to solve large hydraulic problems. Large water distribution systems are now possible to design and analyze through computer system. The following will be considered on this literature view. History of the water distribution networks, which we look how the water or the process of cleaning water came about. Devices of raising water and pumps, which we look at the software which I mentioned before, the likes of Epinet, and also the hydraulics, the whole process of um, abstracting the water from the river to the water treatment plant to the community, and also digital computer, which has made it very easy for um, the engineers to design and also get information to design accurately. Now we look at the classification of water supply system. Water is also an essential for businesses industry to be able to operate in municipality. It's also vital to guarantee that the water is provided to strategical located fire hydrant in order to provide public with appropriate fire protection. Municipality system may be obliged to provide water for a specific service, such as street cleaning, selling of water to constructors for building construction, parks, recreation, other activities. Now we're gonna look at how we're gonna apply the proposed design that is needed by its a local municipality. Now we're gonna look at the methodology, how we're gonna apply this design, and also what um, what components to consider when designing. First of all, look at the material. The material and the components required for this study include the following: physical components, which are reservoirs, tanks, pipes, pumps, junctions, and also appennants. The, these are the physical that plays a huge role in terms of designing and also applying appennants. For an example, for reservoir, this is where the water sources such as lakes, rivers, groundwater is required for the study, is the hydraulic head. And also for tanks, these are storage that are used to store water. Pipes, they transport water from one junction to another. Pumps, these are links that do not have sufficient energy to move water from nodes to next. Junctions, points where pipe joins, and Ethernet where we design and analyze the network. Now we're going to look at the results and discussions. The results of the initial run of the demand-driven analysis yielded unsuccessfully run, and to correct this, the pipe diameter were increased until the positive findings were obtained. For an example, the lecturer gave us initial of a pipe diameter of 300 meters, and we had to increase this until the run was successful. In detail of the velocity and also base demands are laid on the report. A conclusion: the proposed infrastructure will provide a safe, reliable, and sustainable water supply to the project area for many years to come through a communicable standpipes level of service, which ultimately allows for a flush sanitation level of service, meaning that no upgrades to the constructed infrastructure will be required when the level of service is upgraded in future. The pressure within the pipes are within the limits. This means that the water harm is avoided. The township can now receive the water without any disturbance because the bulk reservoir is there to supply the water for 8 hours without pumping. Pipe sizes have been selected according to allowable velocity, which I have explained earlier on. The increase in pipes are also reduced the velocity of the flow in the pipes limits provided by municipality, which is 1.5 meters per second or less. The tank remained as recommended, which is 12 meters high and 34 diameter, as it was provided enough storage for a system without 8 hours of pumping. The two pumps were also sufficient to assist in extraction of water from Nyangwe River and to lift the water from water treatment plant bulk storage. Thank you.